Hello and good evening, everybody. Thank you for joining us for another edition of In the Cosmos, live from the De Anza College Planetarium. As always, I'm your host, Toshi Komatsu, coming to you from the De Anza College Planetarium in Cupertino, California. And this evening, we've got my good friend, Mike Askins with us here. So Mike, why don't you go ahead, say hello to the fine folks out there?
Well, hello, fine folks out there. It's great to be with you again, Toshi. Everybody's wondering, why is Mike all red? Well, I'm in my backyard at the moment with my telescope, and as we all know, astronomers get very familiar with red light because they need to be able to preserve their vision for the dark sky vision stuff. So I'm out here. It's still not quite dark yet, but looking forward to be able to showing some cool stuff about the moon. I know there's lots of other stuff we're going to show too, right, Toshi?
Yeah, but the main focus tonight will be the moon definitely here. So we'll go ahead and get started with all that in just a little bit. But before we get too far into the program, as always, we'd like to thank our sponsors for this program here, the Foothill De Anza Foundation, for their ongoing support for all of our star parties. This is the last star party that we'll be doing for a little while. We're going to take a little break over the summer. So again, thank you for joining us for now. And we'll have more information about what's coming up later on in the program. But we do want to go ahead and wish everybody a happy solstice. That's coming up Sunday evening at precisely 8:32 p.m. Pacific Daylight Time will be the summer solstice, longest day of the year, which for astronomers, a little bit of a sad night because that'll be the shortest night of the year. And so it makes for observing a little bit tricky for us nighttime observers here. But on the longest day of the year, I was looking it up in Cupertino here. It varies depending on where you are on the planet. But in Cupertino, on the longest day of the year, we get 14 hours and 44 minutes of daylight. And for comparison, in the winter solstice in December, we get 9 hours and 35 minutes. So it's almost a 5-hour difference between the amount of sunlight that we get on the longest day of the year versus the shortest day of the year. So we're coming up on those long days here. And you've probably noticed that, again, not quite dark out where Mike is outside. And so we're still getting there. It's getting quite dark quite late. So we're transitioning to that time when we're getting those longer and longer nights. But after the Sunday, then those nights will start to get a bit shorter. And if you had noticed where the sun set tonight, it was setting pretty far to the north of west. And after Sunday, the sun will start setting progressively more and more towards the east until we get to the equinox. And solstice actually comes from two words, sol and stis. The sol refers to the sun and stis refers to standing still. And that's because if you're watching where the sun is and you're watching where it sets from day to day, as we approach the solstice, that the sun doesn't seem to vary very much. If you can catch my meaning there, vary as in V-A-R-Y, doesn't change its position very much as we approach the solstice. When we get to the equinoxes, it varies quite a bit here. So that's coming up astronomically speaking. And of course, tomorrow, just been recognized as Juneteenth. So we also want to wish everybody a happy Juneteenth coming up here. So a little bit of astronomy and some current news here. Again, we're going to focus on, oh yeah, Mike.
I was just going to tell you that just as a sky check, I'm able to see the bright star Spica at the moment.
Oh, good. And Spica, I know, is
dark enough
near to the moon tonight here. And that's an excellent transition, Mike. I'm glad you brought it up here. We're going to go ahead and start off by looking at the sky this evening through Stellarium. Again, we're going to focus on the moon, but to get just a little view of what we expect to see in the evening sky, we're looking at our old friend Stellarium to take a look at the sky. And this is the sky as it would appear right now under idealized conditions here. So again, not quite dark enough. We're looking towards the western part of the sky here. And if you've got a clear view over towards the northwest, that you can see here, again, the sun has set over in the northwest. But if you've got a clear view low to the south or to the northwest, then you'll see a very bright spot there. That bright spot is actually a planet, the brightest planet in the night sky, and that would be the planet Venus there. So nice view of Venus. It's kind of low. We'll get better views of Venus later on in the year, but for now, Venus is visible in the evening sky, sometimes referred to as the evening star. but it is quite low at this time of year, but it is quite bright. If you
Maybe-
look a little bit higher in the sky, it might not quite be dark enough yet. And Mike, you'll have to let me know if you have a read on it. But Mars is not nearly as bright as Venus, but it is in the sky at the moment. Once it gets a little bit darker, you might look sort of above and to the left of Venus, where you might be able to see Mars there shining red, although not very brightly. And so we're taking a look at the evening sky here. Mike already mentioned that he can see Spica up in the sky. So let's go ahead and kind of just give a tour. Looking a little bit higher in the sky is where we can see the moon. So let's go ahead and move our view up here a little bit. There's the moon there tonight, sort of in the southwest, above southwest at the moment. And that blue star that's right next to the moon that you may see in the real sky if you're out there looking at the sky. That star there, that is the star Spica. If I zoom in on the moon just a little bit, maybe I can get that label to appear, or maybe not. Might not quite be dark enough as far as a stellarium is concerned for Spica to show up, or the label for Spica. But there's Spica there. That's in the constellation, or that's part of a constellation that you can see here. It's quite a large constellation. That's the constellation of Virgo, which is the maiden here. And so you can see that tonight, the moon is right in the heart of the constellation of Virgo.
And actually, Toshi, I noticed when I was looking a little bit earlier that the moon is really covering up one fairly bright star there in Virgo called Porrima.
Yes.
Porrima or something like that, Porrima.
Yeah, and occasionally the moon does cover up stars, just depending on where it is from night to night. And so that's sometimes of interest for amateur astronomers to watch when the star disappears behind the moon, and also when the star reappears from behind the moon. So that's sometimes something that people look out for. But again, we'll be focused on the moon, and I'll come back to the moon in a little bit, but I do want to sort of back up here a little bit and focus our attention a little bit more towards the south, where there's a star that's, again, quite low, but also fairly bright there in the sky. As it gets a little bit darker, you may notice that that star actually has a bit of a reddish color to it there. That's a star called Antares. And it's in the constellation that's a summertime constellation that looks a little bit like this. We're just sort of seeing the top half of that constellation there, but that's the constellation of Scorpius, the scorpion there. And sometimes Antares there is considered the heart of the scorpion, but that's something that you can look for, again, these evening nights, summer evening nights that we're coming across this time of year. But so that's something that you can look for in the evening sky here. And one more thing that I want to bring your attention to at this point, as we wait for things to get a little bit darker here, is to go ahead and pan all the way towards the east to one of my favorite sets of things to look in the sky. It's probably because when I first started to learn the sky, it was around the summertime. And that's a time when you can see this star, which is listed, labeled here in Stellarium, called Vega. There's another star down here that's called Deneb in the constellation of Cygnus. And then there's another star down here. And those stars all together, all three of them together, they form a triangle there in the sky. And that's the Great Summer Triangle, sometimes referred to as the Great Summer Triangle. And it's something that we can see in the summertime, in the early evening, in the summertime. It's just coming up in the east. And as we go through the night, that summer triangle rises higher in the sky and passes almost directly overhead. And again, that summer triangle made of the star Vega in the constellation of Lyra the Harp, which looks a little something like this. And then we've got the label up there as well. And then we've got Deneb in Cygnus, part of Cygnus the Swan. And you can see that long neck of the swan there. Sometimes this is called the Northern Cross as well, because it certainly does look like a cross shape there. And then this last star here is called Altair, and that's in the constellation of Aquila, the eagle there. So those are three separate constellations that you can look for in the summertime. And here, just as evening is, or just after sunset in these summer evenings, we can see these three constellations just starting to come up in the eastern part of the sky here. And the last constellation that I'd like to share with you before we head back to the moon is looking more towards the north. And it's a pretty famous constellation and or set of stars that's up there. Probably one of the most famous. People go out, they like to look up at the stars and find different patterns in the sky. I'm circling this pattern right here, and you may recognize it. You may see it in the real sky if you happen to be outside watching this live stream, if you're outside as well. But this is a group of stars. There's 7 bright ones. 1, 2, 3, 4. That one's kind of faint, the faintest of the bunch. 5, 6, and 7. And those are the stars of what we call the Big Dipper, which is connected a little something like this. There's some other fainter stars that make up the legs and the head of Ursa Major, the Great Bear in the sky there. So that's something that you can also find high up in the evening skies here. As I sort of back away here and look sort of down on the sky here, you can see that right now it's kind of high up in the northwest part of the sky, but that's something that you can look for. And in the summertime, it's nice and high up in the sky, so fairly easy to pick out. In the wintertime, the Big Dipper gets quite low. In fact, we lose some of these stars in the feet of the bear here in Cupertino in the wintertime here. But here in the summer now, 6 months, winter is 6 months away. Certainly today, when we're just coming off of a heat advisory for the area here, we're not thinking about the cool weather of winter when the Great Bear gets to dip her feet in the ocean waters. That's part of a story that sometimes gets told about the Great Bear there in the sky. So those are just a few things that you can be looking for in the evening sky at the moment here tonight. But again, I said that our focus would be on the moon. So let's go ahead and see if we can find the moon. Once again, we'll sort of pan back over towards the southeastern part of the sky to zero in on the moon here. And what I'm going to do here is sort of simulate in Stellarium the kind of view that we'll be getting through Mike's telescope that he has already trained on the moon. As you look at the moon, sometimes people think about the different shapes out of the dark areas, and people see things like the rabbit in the moon or the man in the moon. And these dark areas here, those are called maria, or singular is mare, M-A-R-E, which is Latin for oceans or seas. And that's something that people can see just with the eye. But if you have a little bit of magnification, you've got some binoculars even, it's a good thing to be starting off your astronomy adventures with having a binoculars. You can move up to a telescope later. But there's also these craters on the moon here as well. And we wanted to share just a few different features that we might be looking for on the moon here for a moment here. So some different lunar features that we can see here. There's the terminator, which is the dividing line between between night and day on the moon there. And then we have those craters, and there's a few different types of craters, and Mike will be bringing these up as we're looking at the moon. There's simple craters and ones with walled plains and that are impact basins as well. I already mentioned the mare, which are actually places where lava once flowed on the moon long ago. And again, they were once referred to as oceans, even though we don't think that there's any liquid water just lying around on the moon at the moment. And then we have these couple other terms. And Mike, why don't you jump in here? Tell us about these other terms, or these faults and these mountain ranges.
Yeah, the rupes, as you say, Toshi, are faults, and as it says there as well. A lot of the time, the rupes are specific versions of faults where it's not just a crack, but actually one side of the fault is actually higher than the other side. And we're going to be seeing a particular version of that called rupus recta, which some people call, that's what we'll be looking for tonight. I think I spotted it a little bit earlier. Because one side is higher than the other, it appears as sort of a dark line across a very smooth part, one of the mares, and we'll take a look at that. The montes are pretty straightforward, as you might imagine. Montes refers to, from the Latin, means mountain range, and the particular mountain range that we're going to see is more toward the northern part, and when we navigate to that, I'll see if I can show you where that is. We're going to make a tour here, going from the south part of the terminator to the north part. And we've spoken about it before when we featured the moon. The first quarter is a great time to be looking for nice, good contrast features on the moon because the contrast is so good. Toshi, let me go ahead and do just a little bit of adjustment here.
Yeah, and I've switched the view here so that we can see both you and your the view through your telescope to give people a little bit of a preview of what we'll be seeing here with your scope. We'll make this view of the scope in just a little bit. As Mike is adjusting that, let me go ahead and switch over back to sort of a different slide here to talk about the major parts of the craters that we hope to be seeing here. There's the floor of the crater. That's pretty self-explanatory. That would be the bottom of a crater. Sometimes with these larger craters, you might get a central peak, and that's formed sometimes if you've ever seen a pebble dropped into a puddle of water. Sometimes there's a little bit of that water that pops back up in the middle. Well, what happens with a crater, sometimes you have something large that comes and impacts and creates this crater here, but it actually melts the floor, melts the surface here, and actually liquefies it. So there's a little sort of, I like to think of it as a little bloop that comes back up at the center there. And that bloop, once it solidifies, once again, it becomes this central peak that you get sometimes with some of the larger craters here. There's also the walls here and the rims and the ejecta and the rays, and I'll let people sort of read off of this, but just want to make sure, Mike, I didn't miss anything on those descriptions there.
Yeah, that's great, Toshi, especially if we start to fall into referring to them using those terms, make a little more sense for folks as we do that. So looks like I've been somewhat successful getting things sort of back in the view there. And I'm going to go ahead and take this direction. So the crater that we're going to start by looking at is one called Clavius. And I see Clavius in the upper in the upper part of the view there. Let's see here. It looks like it's sort of drifting out here. I'll see if I can fix that.
Yeah, for the view that we're looking at there, as Mike is sort of adjusting the exposure, it's for the largest crater that's in the view there. He's almost got it centered in the view. Thank you for your expert piloting here on the tour, Mike.
Well, that crater is absolutely huge, Toshi. It's a good 143 miles across, and it's sometimes referred to as a walled plain simply because it's so smooth on the bottom. This looks like one where some lava flowed and sort of smoothed out the bottom after the impact site was created. And then also, if you notice right in the middle, there are a couple of other craters. Do you see those, Toshi?
Yeah, I can see those. In fact, I think I can see two that are in the middle of the crater.
Yeah.
And it looks like there's a central peak to that crater as well. And then there's also a crater that looks like it's sort of right on the wall of the crater as well.
Yeah, that one.
The main crater of Clavius.
Yeah, that one is called Rutherford. And yeah, it looks like it hit right so that it was right on the edge there. So really hit the spot there. Clavius is huge, and it's really beautiful to get this view. And you have to be thinking about the contrast here that we're seeing. The sun is over to the left part of the screen, and it's casting a big shadow on one side of the crater. The wall that's on that same side, you see it's very dark. And you can also see that there's some darkness and some nice contrast in Rutherford as well, that smaller crater that's on the edge. Then on the right side, you end up, it's in a perfect spot to be lit up by the rising sun. The sun is actually rising. If you were standing on the edge of the crater and looked toward the sun, you would see it rising over the surface of the moon, sort of like a sunrise on Earth.
And I'd just like to let people know that we have a different view of this view that Mike's giving us This is a NASA view from a map that you can actually download from the internet here. This is from the Science Visualization Studio that's headed out of the NASA Goddard Space Flight Center. And we'll put the link to where you can download your own version of this in the YouTube chat. So we'll go ahead and put that link, and we'll put it in the eventual description for this video that we'll put live as well. But this is it's sort of just a full screen image that you can look at through any image program. I'm just using Photo Viewer here in Windows, but if you're on a Mac, you can just use the preview application here. But again, in this particular view, we're looking at south is at the top of the image here. And that crater that we're focused on here is, again, Clavius. That smaller crater that's right on the wall is Rutherford there. And again, you can see in this view, which is made from images from the LRO, the Lunar Reconnaissance Orbiter. That's where this imagery came from. And what NASA and the SVS, the Science Visualization Studio, has done is they've taken these images from the satellite, and then they've put in the shadows as they would appear at the specific hour. And the time that I chose, it's a little bit later than now. This would be as the moon would appear at precisely 10 p.m. Pacific Daylight Time. So it's a little bit off, but pretty close to what Mike was showing you here. But this is sort of the shadow that Mike was talking about, again, sort of the being illuminated from here over on the left, and then the wall creating a shadow over here. And then it's the other side of the wall of the crater there is fully illuminated by the sun there. But you can kind of get a sense of how deep these craters must be if they're casting these shadows in between. And this is why Mike was saying before that quarter phase is a great time to be looking at the moon because you can see these shadows really well on the moon, and you have a lot of variety to be looking at. Sometimes people think that the full moon might be a good time to look at the moon because then everything's illuminated. And what happens is the moon ends up looking, one, it's very bright, and it actually can kind of hurt your eyes just because there's such a bright thing that you'd be looking at in a telescope. It's kind of like staring directly at a flashlight right in front of your eye. But also, you don't get these shadows that you can see here. Everything is being illuminated from top down. And so you don't get any of these shadows here. And so the moon ends up looking very, very flat. So looking at a time that's not full moon, like quarter moon, is a great time to see some of these shadows and get a great sense of texture on the moon here. And just to compare the view that Mike had and the SVS view, let me back up my SVS view a little bit here. I can get them to be almost the same size. You kind of have to rotate in your mind Mike's view a little bit counterclockwise, just a little bit here. But again, you can see that Mike has got Clavius centered there in the view, like I have with the SVS view on the right side of your screen there.
And that's really pretty close there, Toshi. That's great. Down below Clavius is another one that I recognize, and I can see it in both views, Toshi. I can see it in the SVS map, and I can also see it in the telescope, and that's the crater Tycho, or Tycho, as I sometimes say it. I had an instructor once who told me that Tycho was actually a better representation. Saying it as Tycho was more typical of the language of Tycho Brahe, the Danishman who did a lot of astronomical work, and he had a crater named after him. And Toshi you were actually circling it, eh?
Yeah, I was circling it on the SVS view that I have here.
Yeah.
Let me go ahead and we'll focus on your telescopic view, and maybe you can get it nice and centered for us as well. As Mike is centering it there, again, it's, oops, wrong direction, Mike. But the Tycho one, or Tycho, excuse me, I'm used to saying Tycho, but Tycho there does have a very large central peak that you can see. And that's one of the things that makes it easy to identify when you're looking at the moon there. So again, we've got Clavius centered there and sort of down from Mike's view of Clavius, and to the right of the terminator, or sorry, to the left of the terminator is where we can see Tycho, the crater Tycho there.
See if I can move things up and navigate a little bit south. It's a little tricky. The the paddle that I'm using here. See, did I get that right?
Yeah,
There
that
we
direction.
go.
That's good.
That's better.
Yeah.
Okay, so Tico is there. And let's see, there's another one that's close by that was sort of in between Clavius. You can see a triangle between Clavius and Tico and this other very big sort of eroded looking crater. And that one, the name of that one is Maginus. And let's see, Maginus is something close to about 100 miles across. It's very big. I'm not sure if we said how big Clavius was. It's huge. It's like 140 something miles across. Maginus just a little bit smaller, and Tico considerably smaller. One of the things about Tico, Toshi, that you can't see at first quarter is the fact that when that impact happened, it threw all kinds of stuff. It dug up a whole bunch of light colored material and threw it all over the moon. You know what I mean, right, Toshi?
Yeah, and that caused some of the ejecta that we mentioned on the previous slide there,
Yeah.
showing how you get rays that settle on other parts of the moon. They seem to emanate from from that crater. And there's a classic sort of demonstration that sometimes instructors do when you're talking about craters, is you get a sort of a shallow tub. You can use like a baking, like I would use like a foil baking pan, and you cover it with, you fill it with some flour, and then you cover it with a layer of cocoa powder just because it's a different color. And if you let a rock or a marble or some pebble drop into the tray, then you get this ejecta of the white flour that gets ejected, and it makes a pattern across the cocoa powder that you can see. So that's something you can try for yourself at home, or possibly you may have done that or seen that as a demonstration when things could be done live.
Let's see here. Let's continue to go north here. And again, south is toward the top, I believe, right, Toshi? Yeah.
Yes.
In the view here that we're looking at. So let's see if I can get push the right button here. Wrong way. This way is the way I want to go. I want to go down a little bit farther.
And as you're getting positioned, Mike, I'll notice, or I'll mention also that as you're looking through the nice telescopic view that Mike's sharing through his telescope there, you may notice that the view looks a little wavy, almost like you're looking at something underwater or sort of through water. And that's actually a distortion in our atmosphere. It's actually not too bad. At least the view that we see here doesn't look too bad. I was actually expecting it to be much worse. One of the things that affects how much of this waviness or distortion that you see actually is heat. And since today was a particularly hot day, I was expecting a lot more distortion. But it's not too bad. It's actually not as bad as I thought it might be.
No, it's actually looking a little smoother. I agree with you, Toshi, than I would have expected. And that might have something to do with the way we're bouncing the images back and forth between the two of us. Tico, if we go down below Tico, there's a couple of sort of twin looking craters that are definitely further toward the north or down lower in the view. And there's a big one that's underneath. In fact, to me, it looks a little like our friend Mickey Mouse with a little face, a sort of a circular face, and then a couple of ears up on top. Do you see that, Toshi, that bigger one? That's called Pitatus.
Yeah, and let me switch over to the SVS view so that we can get the labels for everyone to see
Okay.
as well. But yeah, we've got Pitatus
That's it.
that I'm circling here. And then we've got these two sort of twin craters that are almost about the same size. It's kind of a remarkable cosmic coincidence there. Again, about the same size, just above, or at least in this view, above Pitatus here.
So Toshi, what I'm doing is I'm navigating toward the straight wall. And maybe you can see it in the SVS view. It's right next to that tiny little crater called Burt. And it's not labeled. You're right there, Toshi. Yeah, there's the straight wall. So that is also called Rupus recta. And that's the one that's actually a fault where one side, and I believe what it is the side that Toshi's on right now, is higher than the other side of the fault. And so, as it's lit at the moment, it's dark. But if the light were coming from the other direction, which it will many days from now when the phase is different, when the sun is coming from the upper right there, it would actually turn white. So because you'd actually see the ridge, see it as a ridge, and instead of as a groove. And Toshi, I'm going to try and navigate the telescope view so that we can see that.
Yeah. And as you're doing that, I'll mention that that's why the moon is such a wonderful thing to be looking at. And again, even if you don't have a telescope like Mike does, if you've got binoculars lying around, that's you can do a lot of exploring on the moon. But the moon is something that really changes very dynamically from night to night. So there's a lot of stuff that you can see on the moon that looks one way one night. You look a couple nights later, and it might look completely different. So there's a lot of stuff that changes on the moon all the time. So it's a really rewarding thing to be looking at.
So Toshi, Bert is right about in the center, and the camera, the phone is trying to do the focusing there. Bert is in pretty good shape there, and then if you look, you can see the little line there, the dark line there.
Yeah, I can sort of just barely make it out. It's just that small crater that you have almost centered in the view here, just to the left of it. There's it's in your view through your telescope, it's almost vertical. In the SVS view that I was showing, it was slanted, but in your view, you've got it almost vertical there.
Yep. And once again, let's see. Let me look at my notes here. The straight wall is about 68 miles long. So from the dark line there is about 68 miles. And I'm trying to remember or see my notes a little more clearly here. It doesn't say exactly what the difference in height is. I have to look that up, but it's enough to make a difference. And of course, you have to get the lighting just exactly right to be able to see that feature, because the difference in height is not very great. So let's see here. Maybe we can continue going towards the north here. And if I can see if I can get the right view here.
Yeah, and as we do that, as you move along, Mike, looks like there's a question in the chat about Mars, and Ekta Bal is wondering if it will get a ring from Phobos, and what about Deimos? I'm not exactly sure about the question there, but I believe Phobos is on a collision course with Mars. It's expected to crash into Mars, but not for a long, long time, millions of years from now. But when it breaks up, probably won't form a ring. I'm just guessing because it's quite small as far as bodies go. So I don't think it would get a ring. Deimos is, you'll have to correct me if I'm wrong here, Mike, but I believe Deimos is the further out moon of Mars. And I don't recall.
I believe that's true. Yeah, Phobos is the one that's in closer and Deimos is the one that's further out. I'm pretty sure of that, Toshi, but I've been wrong before.
And I think I can't remember off the top of my head if Deimos is also supposed to crash into Mars. I know Phobos for sure. I think if Deimos is also going to crash into Mars, that's not for an even longer amount of time there. But what would be cool is to be on Mars and to be able to see two moons in the sky. They'd still appear quite small in the Martian sky. We have one large moon, but Mars has two quite small moons. People have had different debates about where those moons came from. One of them, at least Phobos, I think, seems to be sort of a rubble pile, and it's sort of barely holding on to itself due to its own gravity there.
Toshi, I think I'm also seeing Fra Mauro. Let's see here. It's that's further north than the Straight Wall, And it's the one that I'm looking at. It's fairly large. There's a couple of small craters. I can't point it out, unfortunately. Why don't you go back to the SVS view and maybe we can spot it and then match it from the SVS view.
Yeah, so what I think I can see in your view here is sort of near the top of your view. I think there's sort of this cluster of sort of what we're looking at with Patatis and sort of
Right.
the Mickey Mouse crater.
Yeah.
And so Frau Moro is sort of following along the terminator here a bit lower. And so let me move my view here a bit. There's a couple of craters also near Frau Moro, which I think you'll probably want to point out because it's also near sort of the Apollo 12 and Apollo 14 landing sites
Yeah.
there
Apollo
as well.
14 actually was very close to Frau Maro. And that's the one that has the little golf story, Toshi.
Yes, so we had Commander Alan Shepard, who became the first golfer on the moon, lunar golfer there. He managed to smuggle a couple of golf balls when he went to the moon, and he sort of made a makeshift golf club out of the equipment that they're already bringing up, and he managed to hit a golf ball on the moon. So the astronauts, even though they had a lot of work to do, they still managed to have a little bit of fun while they were up there as well.
So I think I put Frau Maro right in the middle there, Toshi.
Yeah, I think I agree that it's pretty centered here. Again, it's sort of another Mickey Mouse, not quite as good as the other Mickey Mouse that we just saw, but also sort of a Mickey Mouse shape there. Large crater with two smaller craters for the ears, and sort of at the I guess it's the northern end is where the Apollo 14 landing site was.
And Toshi, I'm also seeing, sorry, I only recently got my pilot's license here, Toshi. I'm having some trouble getting it to go exactly which direction I want it to. But right on the terminator, Toshi, is a very famous crater by the name of Copernicus. And we can only see about one half of the wall. The other one is completely in darkness. After just a few more hours, I suppose, there will probably be some lightening up of some of the details inside that crater Copernicus. And yeah, you're showing it right there in the SVS. Cool.
Yeah, I've got Copernicus sort of centered in my view on SVS, and you've got it pretty well centered there again, half illuminated. And what I'd like to do is go ahead and switch to sort of the full view from your scope just to be able to see it in real time. Again, it doesn't exactly match what I have on my SVS because we're a little bit, your view is a little bit ahead there. So, but yeah, Copernicus, another great crater to be looking at. A lot of detail. Looks like some pretty high walls there on the left side that we're seeing there.
And it's about, Toshi, about 58 miles across if you could see the whole thing, which of course we're only seeing about half of it at this point. And to the left of that is another standout crater. It's called Eratosthenes, and it's about 36 miles across. And if unfortunately our view here is not quite, looks like we got a little bit too much turbulence to be able to see the feature. I can imagine it nicely, and I don't suppose that helps anybody, but there are supposedly central peaks in the middle of Eratosthenes.
Well, through the magic of NASA here, we can see sort of, again, a similar view to what you have, a little bit rotated, but again, we've got Copernicus right over here. In your view, Eratosthenes, I always have trouble saying that, is immediately to the left of Copernicus in your view. In my view, it's sort of down and to the left a little bit. And I think the feature that you wanted to talk about is this whole sort of, it almost looks like a mountain.
That's right.
That's trailing off from Eratosthenes here.
Yeah, that's called Montes Apenninus, named after the Italian mountains on Earth. And Toshi, we're actually looking at a very small portion of a very huge impact basin called Mare Imbrium, or the Sea of Storms. And this was this is the largest impact basin on the moon. And we're seeing a little bit more of it tonight than I had expected to. Very cool. And I need to stop talking and remove my telescope view. Toshi, maybe you can talk a little bit about that giant impact basin there.
Yeah, so let me go ahead and I'll switch over to sort of the full view of SVS so that folks can see here. But this Mare Imbrium is this again, this sort of very large impact basin. It's kind of broken up here. It doesn't look like a continuous crater wall that we can see. Part of it's in shadow here, but again, the part that we're talking about, sort of just this part here. And again, if you use your imagination, you can kind of imagine that all of this is sort of connected in a fairly circular shape here. We do that sometimes with craters here on Earth as well, as sometimes we don't see all of the crater wall. Sometimes we just see sort of a small section of it. And they just look like mountains. But once we got satellites, we're able to see that actually there's some more to it and that it is connected in a circular fashion here. But I can zoom in quite easily, a little bit easier than Mike, because this is just a still image that I'm looking at. But again, a very long mountainous region, this Montes Apenninus, 370 miles long here. So quite a long, large feature. And sort of at the end of this feature is where the Apollo 15 mission landed here, as noted on the map.
So Toshi, I'm having trouble actually seeing where I'm going. Can we go back to the telescope view so I can see it a little more clearly?
Yeah, so it looks like to me you're drifting off.
I am, yeah.
To the side there a bit.
I'm hoping I'm coming back now.
That's a pretty good view of the Mare.
And there it is. Yeah, that's a large part of Mare Imbrium there.
Yeah.
All
Again,
kinds of
in my view, it's sort of almost at a 45-degree angle. On your view, sort of coming off more towards sort of in almost a horizontal line towards the left here. And again, let me go ahead and focus in on your view so that we can appreciate the full telescopic view that we're getting tonight.
Yeah, if you sort of walk down the terminator there, go past that big basin, there's another crater by the name of Plato. All of these craters named for famous ancient astronomers and philosophers as well. And Plato is there. I look in my notes here. And Plato is what they call a walled plain. Usually they name these things depending on how big they are across. And Plato, I think, is about 63 miles, something like that across.
Yeah, and that's that sort of large crater that's in the lower left corner of the view that we have at the moment through your scope. Again, let me crossfade so that we can take a look at both your view and my view here. Plato, this crater that's down here on the corner, almost again right on the northern wall. I have to keep reminding myself that this is a south up view that we're looking at here.
Yep.
But on the northern wall there, Plato there. And then there's another nice crater sort of up a little bit higher, sort of not quite in the middle of the Mare Imbrium here, but sort of around here. And that's Archimedes.
Archimedes,
well.
yep. And Archimedes, about 52 miles across, a flooded crater. When we talk about flooded craters, Toshi, I'm not sure if we talked too much about the mares there. Maybe you did while I was focusing on getting the telescope in the right place. But these impact basins fill in with lava, and that's what makes them look very smooth, and also what makes them look dark. Because of the basalt in the lava material, it tends to be darker than some of the material that's found at other elevations and in the mountains and so forth. So that's why they sort of look dark like that. And you can see that huge plain is quite smooth. It's rather remarkable.
Yeah, and that lava flow, it's an ancient lava flow. So if you've ever been someplace here on Earth, you don't have to have gone to the moon. But if you've ever been someplace here on Earth where lava has flowed somewhat recently, like especially in Hawaii or maybe in Iceland, someplace where there are active volcanoes and there have been lava flows. As the lava flows, obviously it's sort of orange and molten, but once it cools, it becomes this dark colored rock. And that's what the dark mare on the moon is. It's that same dark colored rock, basalt rock. That has smoothed over any older craters that might have been there. And in fact, looking at sort of cratering and what's layered on top of other craters is one way that astronomers will date objects in the solar system, anything with a solid surface. Not so useful on, say, Jupiter or Saturn. There's no craters to be found on those planets because they're gas giants. But around some of the moons that surround those planets, as well as our own moon, and even here on Earth, there are, you look at cratering patterns, and that can give a sense of the age that astronomers can sometimes do some extraction.
Well, Toshi, it looks like we've reached the north part of the Terminator there, and that was sort of our goal, is to take the whole Terminator. Do you want to, shall we take a break from the moon? And is there anything else that we wanted to? I think there's another question in the chat that says, what about Andromeda, Milky Way? Oh, the Milky Way collision. Yeah. It turns out that just about every galaxy is speeding away from the Milky Way galaxy. The vast majority of them are, but there's one that's coming our way, and that's one called Andromeda, the great galaxy of Andromeda. It's one of the closest ones, and it looks huge in the sky compared to lots of the other craters. I understand that if you look carefully at the direction that it's traveling right for us. Toshi, should we be afraid of that?
No, I wouldn't worry too much about it. And before I answer more, I will say that if you have any other astronomy related questions or questions about the moon, go ahead and put those in the YouTube chat, and we'll see if we can answer some of those. But so go ahead, and if you have any questions, go ahead and put them in, and maybe we'll be able to answer them. But to go back to this question about the collision between the Andromeda galaxy and our own Milky Way galaxy, that's not something that we have to worry about for millions of years. It's not anything that I lose any sleep over. But there has been a suggestion that when the two galaxies merge, that because it's the Milky Way galaxy and the Andromeda galaxy, that there's been a suggestion that we call the Milkdromeda galaxy, because it'll be the two galaxies merged together. But if you think about what it might look like, you might think that, oh, they're going to crash into each other and you'd have all the stars that are crashing into each other. And that's not really what we expect to happen, actually, because there's a lot of space in space. That's why we call it space, after all. And so there's a lot of space between the stars. So even though you have these galaxies that are colliding into each other, we don't expect very many of the individual stars to collide into each other. Certainly they'll pass each other, and they might get very close, and you might get different gravitational effects that are happening, but you won't get too many stars. And one analogy that often is made about when you have galaxies colliding is that, imagine if you have a handful of marbles in your hand, or maybe in my hand, and I'm on one end of a gymnasium somewhere. Mike, let's say, has his own handful of marbles. These marbles represent stars in a galaxy, and he's somewhere else. He's on the other end of that gymnasium there. If we take our two handful of marbles and we roll them towards each other, compared to the size of the gymnasium and the size of the marbles, you wouldn't expect very many of the marbles to collide. Several of them probably pass right past each other and not have a collision. That's what we expect, the sort of view that we would get with colliding galaxies, that the individual stars, like those individual marbles, will probably not collide, because there's quite a bit of space between them compared to the size of the entire galaxies there.
Toshi, I see another question in the chat. That's a very good question. Are all craters in the moon created by meteors? Because we know that on Earth, there are craters that are not impact, but that are volcanic in nature. But the ones on the moon are pretty much created by impacts. They may not be small. We may not refer to them as meteors. We might refer to them as asteroids, for example, if they were like big enough. But by and large, I mean, there are things that look like mountains, but even those are the results of impact, because there's a large amount of material that's hitting and sort of forcing material out into this in crater-like shapes. They're just very, very large. So Toshi, my answer would be that, yeah, the craters in the moon are just created by impact. Would you say the same thing?
I would, and I'll also note that at least one, maybe more than one, was not a natural meteor. We have crashed a couple of things into the moon. occasionally it's been intentional as well. Occasionally there were things that we didn't mean to crash into the moon, but there were at least a couple of spacecraft that have crashed into the moon. So they've created new craters on the moon from stuff that we've sent. But yes, by and large, the craters that we see on the moon, they're caused by things crashing into the surface, not so much by volcanoes like we would have here on Earth, where you get some volcanoes that are creating craters on the moon. All impacts. Most of them, 99.99999% of them, natural things flying around in the solar system. But occasionally there's a couple of things that are craters that have been formed by us people crashing things onto the surface of the moon there.
Well, it really amazes me how much stuff hits the moon, Toshi. It turns out that what some people refer to as the soil of the moon, which scientists call regolith, is actually the result of very, very, very small particles falling and being attracted by the moon and falling onto the moon. So the footprints that we saw on the moon of astronauts that made it when they were exploring the moon, that's what that material is. The stuff that they're walking on is not soil in a sense, but it's actually the results of all kinds of collisions of meteoroid material, micrometeoroids.
Yeah, and what the astronauts found is that the soil on the moon, which again we call regolith, is very jagged. So if you pick up some soil from here on Earth, it's relatively smooth. But when you pick up the soil, the regolith on the moon, it's very, very jagged, and that actually caused some issues for the respiratory systems for the astronauts when they're on the moon, because this stuff, it got everywhere and stuck to everything everywhere. Again, it had a little bit of an electrostatic charge to it, and it was sort of a real problem. It's one of the engineering issues that we have to think about on our efforts to return to the moon. And there's efforts by NASA through the Artemis project to send people once again to the moon in the not too distant future. But that's one of the things that they have to contend with, is all this very jagged regolith that you wouldn't want to get into your lungs, because again, you have these very, very sharp, jagged pieces there. So another engineering challenge here.
We're getting some more great questions here. How old is the youngest crater? Would we ever see a live crater impact that's not man-made? And Toshi, I believe that the Lunar Reconnaissance Orbiter has seen impacts of craters being made. Is that your understanding too?
Yes, and the Lunar Reconnaissance Orbiter was in orbit around the moon, so it's much closer.
Yeah.
To see a live crater impact from Earth would be a lot more difficult, just because we're much further away, and the moon is being impacted all the time by tiny things. But large things, we think most of the large things have already crashed into most things already. So it'd be very difficult to see an impact from Earth happening on the moon now. Now that mission that I mentioned earlier, where we intentionally crashed something into the moon, there was some hope that we might be able to see that. Amateur astronomers were looking at the moon to see if they could capture that impact happening. Unfortunately, they weren't able to capture that impact. But one of the reasons for that impact, that was from the LCROSS mission, LCROSS. And that was impacted on the moon specifically because they wanted to figure out how much water might be locked into the regolith, into the lunar soil. And one way to do that was to crash something into the moon and then look at the plume that gets ejected from the moon, and then study it spectroscopically to figure out if there's any water. And they did that, although we weren't able to see the impact. Once they studied the plume, they found that there was actually quite a bit of water on the moon. It's again just sort of locked up in the soil itself. But that's good news for if you want to go to the moon, and specifically if you want to set up a base on the moon, which people have dreamed about for a long, long time. But one of the things that we all know that we need to survive is we need water. If we have to bring our water with us from Earth to the moon, that gets very expensive and it's very bulky. But if we can mine the moon for water, that is a very hopeful sign. It means we don't have to bring it with us. We're more able to live off of land, as it were. And so LCROSS was able to confirm that there is water in the moon that is mineable. We would be able to mine the rocks on the moon, mine the soil to get some of the water that we would need for a base on the moon.
I'm looking, boy, all of a sudden, Toshi, there's a whole bunch of questions in the chat here, and they're great questions too. Somebody asks, fifth grader asks, how did they choose the landing spots for Apollo missions? Um, and a lot of time that was based on trying to figure out the most likely places that there was answers to questions about early parts of the moon's formation. Right, Toshi?
Yeah, anytime we're landing something on another planet or on the moon, whether there are people involved or not, there's always some sort of discussion about where's the best place, and it depends on what your objectives were. I think for the Apollo 11 mission, that first mission that landed humans on the moon, they were looking for someplace nice and smooth because there are a lot of unknowns about the surface.
Yeah.
There was some who thought that that the surface would be kind of like not quite like quicksand, but the surface would be very soft. And if you landed anything like a spacecraft on it, it would actually sink on the moon. So they were going for someplace just sort of nice and flat that didn't have a lot of rocks. But as we started going back to the moon, there were some more scientific questions that we wanted to answer that were either near mountains where we could sort of hike out, or in some of the later missions, drive a rover out to the moon to collect samples. Some of them were sort of right in the Maria, some of them were just outside of the Maria. So there was an effort to choose different areas depending on what sort of samples the scientists were interested in bringing back. So there's a variety of things that go into the decisions. Mainly you want it to be safe. That's sort of the top priority there. But then sometimes there are other scientific reasons for choosing, and it just depends on mission to mission.
Let's see. Does the moon change its trajectory slightly every time it's been hit by an object? Well, I guess you would have to say yes, but the amount of change in trajectory might be arbitrarily small because you're talking about a hugely massive body, the moon, and much smaller objects hitting it. Certainly, early in the formation of the moon, we know that there were huge collisions, and those end up causing could have very likely caused significant variations in the trajectory of the moon. But nowadays we don't see those sizes of impacts.
Yeah, I would say it's one of those things where you could, in theory, you could calculate the change in trajectory. It's a good problem for first-year physics students to do, and astronomy students. But again, the actual practical amount that the moon would be affected would be very, very small. It'd be very difficult to measure, but again, something that could, in theory, be calculated by, again, first-year physics students.
Well, Toshi, I think we've hit most of the questions there. I know it's getting, it's about time for us to wrap things up here. What shall we do next here?
Yeah, well, I just sort of want to thank you, first of all, Mike, for being out there with your telescope.
Oh, sure.
And we appreciate you doing that for us and giving us some great views here. I know a couple of our last star parties were kind of clouded out, so it was nice to get some clear weather for this last one here. But go ahead and say goodbye, and then I'll wrap things up. But anything that you want to add, Mike, at the end?
No, I just can't wait until maybe at some point we'll be able to get folks to come back into the planetarium and get some face-to-face connection there again. We're getting a lot of electronic connection, and that's good. I'd like to wish everybody a good summer, and thanks for joining us tonight and letting us share some stuff that we love with you.
All right. Well, thank you, Mike. And once again, we'd like to thank our sponsor for the evening, the Foothill De Anza Foundation. Your support is always very much welcome. And we appreciate everyone tuning in tonight. Hopefully you enjoyed yourselves, and I hope everyone stays cool, certainly over the next few days here, as again, we're sort of still in this heat wave, but we appreciate everyone's time this evening, and we hope you enjoyed yourselves. Again, this is the last star party that we're going to be doing. We're taking a little break of these from these over the summer, although we'll be still doing things on our social media and on our website. So do check those out as well. And I think that's probably just about it. We'll still be posting things on our YouTube channel here. So if you have any questions, there's lots of ways to get in touch with us. But from this evening here at the De Anza College Planetarium in Cupertino, I'd like to once again thank everybody. Have a great night. Have a great summer. Happy solstice. Happy Father's Day. Happy Juneteenth. Lots of things to celebrate at the moment here. So thanks, everybody. Stay safe, stay healthy, stay cool, and we will see you next time. So thank you all very much.